Hello everyone, hope you are all doing well. So here you have a question from solution chapter based on ideal and non-ideal behavior of solution. So let me check whether you can answer this particular question. So the question goes like this. Which of the following solution is an example of a non-ideal solution showing positive deviation? Option A, acetone and carbon disulfide. Option B, chlorobenzene and bromobenzene. Option C, chloroform and benzene. Option D, acetone and aniline. Go through this question again and mark your answer. If you could answer it right, it's excellent. We will see answer to this particular question at the end of this video. Usually what happens is when we see such questions, we often get confused. It's because we study and we memorize a lot of examples related to one particular concept. And it is difficult for us to recall the examples which we have studied, especially during the examination. It's because of a tension we get confused between the examples that we have studied. And we end up in marking wrong answers instead of marking the right one. So for this particular question, that's related to the concept of ideal and non-ideal behavior of the solutions. In case of non-ideal solutions which are showing positive and negative deviations, how you can identify among the examples which one is showing a positive deviation, which is showing a negative deviation, and which is showing ideal behavior. I have brought to you a trick that you can easily identify which is ideal solution and which is non-ideal solution. So before moving into the trick directly, let us list the examples for the solutions which are exhibiting ideal behavior and those solutions which exhibit non-ideal behavior. That is, which are showing positive deviation and which are showing negative deviations. Wait for a minute and think what are ideal solutions and what are non-ideal solutions. Ideal solutions are the ones which obeys Raoult's law over all concentration. And those solutions which do not obey Raoult's law are classified into those solutions which is showing positive deviation and the ones which is showing negative deviation. Come on, now let's list the examples. Examples for ideal solutions are N-hexane and N-heptane, chlorobenzene and bromobenzene, N-butyl chloride and N-butyl bromide, ethyl iodide and ethyl bromide, benzene and toluene, also now let us list a few examples for non-ideal solutions which are showing positive deviation as well as negative deviation from Raoult's law. Few non-ideal solutions showing positive deviations are acetone, methanol, acetone, carbon disulfide, water and methanol, water and ethanol, carbon tetrachloride and methanol, cyclohexane ethanol, let's also consider a few examples for non-ideal solutions showing negative deviation. So the examples are acetone aniline, methanol and acetic acid, a mixture of water and hydrochloric acid, acetic acid and pyridine, chloroform and benzene, water and nitric acid, acetone and chloroform. If you look into these examples that we have listed for ideal solutions and non-ideal solutions, you can correlate or you can find some relation among these examples that we have listed. For example, if you consider ideal solutions, you see N-hexane and N-heptane, both are alkanes. So means these liquids has same type or its nature is same. They usually fall under the examples of ideal solutions. If you consider chlorobenzene and bromobenzene, they are of similar nature. N-butyl chloride and N-butyl bromide. And similarly ethyl iodide and ethyl bromide, benzene, and all these examples which we have listed are the liquids of same type. When they combine, they form ideal solution. So if the liquids are of same type, then the solution that we get is ideal solutions. So the trick here is that examples for ideal solutions are those liquid mixture in which you have same type of liquid. So the examples that we have already listed, from that it's very clear that liquids of the same type are the examples for ideal solution. Now looking into the examples of non-ideal solutions which is showing positive deviation. Mostly the alcohols, carbon tetrachloride and carbon disulfide falls under the category of positive deviation. So here the trick that you have to remember is that mostly they are alcohols, carbon disulfide or carbon tetrachloride. In the examples, we have listed acetone and methanol. So this OL means it is alcohol. Second example, we have acetone and carbon disulfide. So since we have CS2, this mixture is an example for non-ideal solution. Third, we have water and methanol, alcohol. Water and ethanol, again alcohol. In the next example, we have CCl4, carbon tetrachloride and methanol. Okay. So OH group is there, CCl4 group is there. So this is an example for non-ideal solution showing positive deviation. Finally, we have cyclohexane and ethanol, again an alcohol. So mostly when we have alcohols, CS2 and CCl4, those solutions are examples for the ones which is showing positive deviation. Now looking into the examples of negative deviation. So they are mostly acids. When in the two liquids A and B, if any one is acid, then usually they exhibit negative deviation from the Raoult's law. So that's they are non-ideal solutions which is showing negative deviation. If you consider the examples, you can see acetone, aniline. Okay, this is an exception that you can note. Okay, then you have CH3OH methanol and acetic acid. So an acid, water and HCl, hydrochloric acid, acetic acid and pyridine, chloroform and benzene, again an exception. Then we have water and nitric acid, HNO3, again acetone and chloroform, this is an exception. So using this trick, 95% of the questions you can answer it correct. Instead of getting confusing and spoiling the whole question, at least 95% of the questions you could make it right by using this particular trick. So when we have liquids of the same type, they are ideal solutions, and when we have mostly alcohols, CS2 and CCl4, they are non-ideal solutions showing positive deviation. Most of the cases when we have acids, usually those solutions are non-ideal solutions which is exhibiting negative deviation. Hoping that you have understood this particular trick. So according to the trick, when two liquids are of same type, then we have ideal solution. If the two liquids are of opposite nature, especially in that when we have alcohols, CS2, that's carbon disulfide, and CCl4, carbon tetrachloride, they are non-ideal solutions showing positive deviation. Mostly in some of the examples when we have acids, they are non-ideal solutions which are showing negative deviation. Now again, we shall look back into the question that I had asked in the beginning of this particular video, and now let us see whether you can answer that particular question. Here is the question, and you have to identify the solution that is exhibiting positive deviation. Now let us look into the options. First option, we have acetone and carbon disulfide. So here you see we have carbon disulfide, CS2. Can you remember which type of solution is this? So when we have alcohol, carbon disulfide, CCl4, it is showing positive deviation from the Raoult's law. And when we have chlorobenzene and bromobenzene, so chlorobenzene, bromobenzene, almost of the similar nature. So this is an ideal solution. Then we have chloroform and benzene, which is showing negative deviation. We had studied as an exception when we considered example of negative deviation. Similarly, we have acetone and aniline, which is also showing negative deviation. So according to this question, they have asked us to find which is exhibiting positive deviation, and here we have acetone and carbon disulfide, which is exhibiting positive deviation. Hope you have understood the trick. To check it, answer the question that is posted in the comment section below this video. If you want to learn more such tricks, stay connected with us and keep learning. Thank you for watching.